Hi guys, welcome to Egg Guru channel. So in this video we are going to discuss about generated differential protection. So before going to the video, please watch the content of other videos. If you like the content, do subscribe the channel. Generated differential protection. The protection of a generator is very much essential in order to avoid the catastrophic failure of a generator or in order to avoid the further damage of a generator. So here in this video we will discuss the generator differential protection using a differential relay 87G. So we will explain with the characteristics of a differential relay. So coming to the differential protection, as name indicates, the basic operating principle of a differential protection is to calculate the difference between the current entering and leaving from a protected zone. If the protected zone is generator, so then the current entering into a generator must be equal to current leaving from the generator if there is no internal fault. If there is an internal fault, then these current entering and leaving are not equal, so then this differential protection will operate. Similarly, in case of a transformer, differential protection of a transformer will operate so whenever there is a difference between the current entering into a transformer and current leaving from the transformer. So here, this differential protection will detect the generator internal short circuits and the ground faults within the generator. So simply differential protection will detect the internal faults in a generator. So here we can see the single line diagram of a generator using the differential protection. So here we can see by using two CTs we are detecting the currents. So here we are placing one CT here, that is the 1000 by 1 ampere CT. Similarly, in neutral side also we are placing another CT, that is also 1000 by 1 ampere CT. If there is a flow of 1000 amps in the primary, then the secondary current is 1 ampere. Similarly, in the line side also, if the current is 1000, then the secondary current is 1 ampere. So these two secondary currents will be detected by the differential relay 87G. Depending upon these two currents, the differential relay will operate. In order to understand the operation of a differential relay 87G, we need to understand the two currents. Those are, one is the differential current, that is ID, that is the phasor sum of the phase current and the line current. So here, so this is the phase current. The phase side of a generator is the phase current, and the line side current we will call it as the line current. The differential current is nothing but it is the phasor sum of the line current and the phase current. Similarly, another term, the bias current. The bias current is the average of the phase current and the neutral current. So here, so when this differential protection should operate, if there is an internal fault within the generator, then only so this differential relay should operate, and then it should safeguard the generator from the external conditions. If there is an external fault, so this differential protection should not be operate. The external faults can be taken care of other type of protections that we will discuss later videos. Similarly, in normal conditions also, this differential protection should not be operate. So those three cases we will discuss in this video. The case one is in normal operating conditions. If there is no fault within the generator or outside the generator, the protection should not be operate. For case 2, if there is an external fault outside the generator, so then these protection should not be operate. These external faults can be taken care of another protection schemes. In case 3, if there is an internal fault, so then this protection should operate. Nothing but this differential protection is exclusively for the internal faults of a generator. If there is an internal fault, so then this protection should operate. So we will see one by one. The case 1, in normal conditions, the protection should not operate, so that we will see. In normal conditions, the generator will supplies the electrical energy to the load, so then that current is 1000 amps. So then if we are using the 1000 by 1 ampere CT, so then the secondary of this CT is 1 ampere. Similarly, in neutral side also the secondary current is 1 ampere. So here we can see the line, the neutral current is 1 ampere. Similarly, the phase current is also 1 ampere. So then from this the differential current ID is equal to, so that is the phasor sum of the, so these two currents, that is 1 plus 1, 1 minus 1, that is the 0 amperes. The differential current is 0. Similarly, the bias current is the average of phase current and the line current. The average is 1 comma 1, the average of 1 comma 1 is 1 ampere. So then the characteristics of 87G relay will be like this. So these are the operating area of a generator. So this is the operating area of a generator. So this is the operating area, and this one is the non-operating area. If you see here, the ID is equal to 0 and the bias current is 1 ampere. So then the operating point will be here. So that will be in non-operating area. So then, so this differential relay 87G will not send any command to the protection devices. So then, so this protection will not operate. So like this, in normal conditions, the protection should not operate because there is no difference between the current entering and current leaving from the generators. In case 2, if there is an external fault, so then the protection should not operate. So here also the same condition. So here the neutral side, the current is 4 amps, the phase side, the current is 4 amps. Then the differential current is, it is the phasor sum of both the currents. The 4 minus 4, that is 0, and the bias current is average of the two currents, that is 4 comma 4, 4 amps. So coming to the characteristics of the 87G differential relay, the differential current is 0 and the bias current is the 4 amps. So here the operating point will be here. So that is in a non-operating area. So then this differential relay 87G will not send any command to the protection devices. So like this, for an external fault also the protection should not operate. So here the operation principle is same. The current entering into a generator is equal to current leaving from a generator. If there is a internal fault in generator, so then this internal fault, depending upon the intensity of the fault, it will draw the more current. In this case we are considering the fault current is 5000 amps. So this 5000 amps will be supplied like this: 1000 amps from neutral side and 4000 amps from the line side. So then similarly the secondary currents is 4 amps and 1 amps. So in this case the differential current is the phasor sum of two secondary currents, that is the 1 plus 4, 5 amps. Similarly the bias current is average of 1 comma 5, that is equal to 3 amps, 6 by 2. So coming to the operating characteristics of the differential relay, the differential current is 5 amps and the bias current is 3 amps. So 3 and 5, so we will get the operating point here. So then this will send the command to the protection devices to operate, and then we can safeguard the equipment by using this differential protection. So like this, the differential relay will operate depending upon the fault locations. If there is an internal fault, then only the differential relay will operate. So if you see here, there is a slope here. So why this slope is present? So this, or this slope, we can call it as K2. So here the slope is K1. K1 is equal to 0. So in order to accumulate nothing but in order to provide the CT errors, nothing but in order to add the CT errors, so these K1 and K2 are given here in these characteristics. So these CTs will have some errors. Depending upon these errors, the slopes k1 and k2 are present. So if you want to know the detailed analysis why this k1 is equal to 0 and there is a slope is k2, the ds slope is present, so then you can comment in the comment section, then I will make another video for this k1 and k2. Nothing but we have the other characteristics, those call it as a ds slope characteristics of a differential relay, so that we will discuss in another video. If you want the detailed analysis about this what is CT error, how this CT error is accommodated in this 87G characteristics, so that we will discuss in another video. If you want these analysis, please comment on comment section, so then we can discuss in the another video. Thank you.